Jacob Shodd is an engineer who enjoys building things, breaking things, and building things that break things. He spent the first few years of his career working in DevOps before transitioning to focus on security. Since then, he's worked in a variety of areas, including penetration testing, cloud security, developing automated security tooling, threat modeling, and is currently working as an application security engineer at Smartsheet. In addition to work, he spends a fair amount of time mentoring junior engineers and bootcamp students to help them find their way into the wild world of tech. Take it away, Jake.
All right. Can you guys hear me?
Yes.
Perfect. Okay, so as you might have guessed, we're going to be talking about threat modeling today. Now, depending on your background, this might be something that you've run into, something you've heard about, or something you've just kind of, attributed to your company's security team. Either way, we're going to dive into it and kind of bring you guys up to speed. So I always think it's important to cover what this talk is and what this talk isn't. What we are going to cover is, what is threat modeling from a high level? The 4-question cycle that we're going to go through as we're threat modeling an environment, the benefits to be had, common obstacles, etc. What this will not cover, unfortunately, after this 45-minute talk, you're not going to have a step-by-step guide, the total security success. You're not going to be able to eliminate all of your vulnerabilities, and this isn't going to be a perfect solution for your team. That part comes from you guys. So let's get started. So what is threat modeling anyway? So threat modeling, when you first hear it, you think cybersecurity, you think really technical. That's not true. You threat model every single day, whether you know it or not. So when you're driving down the highway and, you're looking to merge into the other lane, you check your rearview mirror, you check your side mirrors, check for any oncoming vehicles, and then you merge. That is a threat model of your current situation. You are looking for any external entities that you don't have control over and predicting any scenarios where they could cause you harm. So when we talk about threat modeling in software development, we're looking to use that same mental process and just adding a little bit of structure to it. So what's one of the most important attributes about threat modeling? It's flexible, right? It's not a set of technical guidelines. It's more of a process of thinking. The reason why this is important is because you can make threat modeling work with your system. There's not a certain set of requirements that you have to check boxes for. You can mold it to work the way you need it to work. So the kind of high-level outcomes, we'll get into this with benefits, and as we talk about this process in general, you're going to get complete and detailed data flow diagrams tailored for threat modeling. You're going to get a structured list of threats, basically saying, hey, here's my application, and now I understand, what could happen. You don't know what will happen, but you know what could happen, and then a proper way to track those threats. These are all great things, but implementing threat modeling is not going to replace your security team. Threat modeling is not a replacement for penetration testing, vulnerability scanning, secure code audits, and bug bounties, things like that. Threat modeling is primarily for the development team, right? It's for your project managers, for your development engineers, all right? This is something where security can help you with, but the highest levels of success here are going to be whenever it's driven by the development team themselves, and we'll get into that a little later. While you won't replace your security team, they will love you for it. There's little things that make you happy when you're a security engineer, and a development team coming and asking you for security advice with a fully detailed threat model, full diagrams, list of possible threats, bug tracking of those threats. That is fantastic. So let's get started with threat modeling. I've done enough kind of high-level talk. When we talk about threat modeling, we can really boil it down to 4 questions, and it's the general cycle that's going to help us add structure to this whole thing. So what are those questions? What are we building? What could go wrong? What are we going to do about it? And did we do a good job? All simple questions, and as you go through and you answer these questions, it's going to help you get an idea of what your current threat landscape is. An important thing to mention as I go into these talks is you don't need to get everything 100% correct to be useful, right? We're not looking for a perfect threat model. We're looking for a useful threat model. So let's get started. What are we building? It's a simple question, and depending on your background, you can answer this to a varying level of technicality. So the idea of threat modeling is we're searching for threats, right? But before we can find those threats, we need to know what are we working with. And existing diagrams are great. Let's say you already have an environment out there, you're already running in production. So if you have existing diagrams from that, that's a great start. Generally, they're missing some of the information pieces that we need, but we can add those in later. An important thing to note, architectural diagrams are not threat modeling diagrams. They're great and they hold a lot of useful information, but sometimes they're too noisy. Sometimes they don't include like the specific information that we need. But once again, great starting point. And if all you have are architectural diagrams and you can't get time to do, another diagram on this application, you can still use it. Like I said, you just need something that's useful, not necessarily perfect. Personally, I prefer data flow diagrams for this, and just because it's a bit of an easier thing to understand, a lot of people have worked with them. That's what we're going to use throughout today's examples. So data flow diagrams. When we're looking for threats, we need to know exactly who talks to who and how they do that. So if we have a bunch of microservices, right, we need to know which services are talking to each other and how they're doing that. That comes into play a little later on. So data flow diagrams, they give us a solid way to do this in a way that most engineering folks are going to understand. Just about every software engineer, project manager, architect, they've seen a data flow diagram before. And if they haven't, it's simple enough that they can pick it up rather quickly. And I know a lot of you are thinking, okay, we use data flow diagrams, we're good. There's some threat modeling specific things that might differ from your current data flow diagrams. So before we go a little further, we're just going to talk about the really high level elements that we're going to be using for this. So let's see, I have my laser pointer here. So going from left to right, we have the sharp-edged element here for an external element. In our examples, this is going to be a user. This is going to be someone calling your API. An external element is something that exists outside of your environment that you do not have any control over, but you are still exchanging data with. Going to the right, we have this dotted box that we're calling a trust boundary. A trust boundary is something we're going to go into detail a little later because it's one of the more confusing topics when we get into diagramming for threat modeling. But the easiest way to think about it is it divides two sections of your environment that hold different levels of permission. And we'll get to that later. Thirdly, we have the process, and this is going to be anything that's processing information. This can be your API. This can be a piece of automation that's handling data, just about anything, right? Then connecting all of these elements, we have data flow. That's pretty self-explanatory. That's any time that data is moving from one object to the next. Depending on how granular you're getting with your diagrams and how much improvement you're doing on this diagram over your weekly sprints, you might get more and more detailed. You can show, for example, if this external element talks to this process over different ports, right? You could have a different data flow for, port 80, port 443. If they're having SSH traffic, it might be port 22. Things like that, just to get more granular view on your data flows. But today we're going to keep it simple and just have the representation that we are transferring data. Then two horizontal lines. This one's kind of up in the air. I'm a fan of, the soda can aspect for like data stores and things like that. But traditionally for threat modeling, our two horizontal lines are data store. This, like I said, this isn't an architectural diagram. This could be used to show a configuration file on a hard disk. This could be used for a specific table in a database. This is anything that is rather static, that is storing information that we're going to either read or write from. Okay, so going back to trust boundaries, they can be a little tricky. And this is, I know personally, when I got started, this is where I had a lot of confusing moments. Coming from an operations and architectural background, they trip you up a little bit. So you may also hear them referred to as trusted zones. So trusted zones is referring to the area within the trust boundary, the boundary being that dotted line. And as I said earlier, they divide areas that have different levels of trust. So this can mean a lot of things, right? This can mean a different VPC that has different rules, right? Different networking rules. This could be used to identify different accounts on the same system. So if we have, like in our next example, let's say we have, as a super, super high level example, we have a Linux server here, and that has its own trust boundary from any external element. And within that server, we have two accounts. We have the root user that has a process in it that we're calling admin tools, and we have the MySQL user that's running MySQL. The reason why these are in two different trust boundaries is anything running in the root user trust boundary has vastly different permissions than what the user in the MySQL user trust boundary or trusted zone has. As you might guess, we don't want MySQL to be able to execute code as root. So we have a boundary kind of showing that separation. An important thing to note when you are building these diagrams, just because something doesn't exist, let's say MySQL does have access to run commands as root, it shouldn't, right? So it shouldn't have those permissions. So we're still going to draw that boundary. And the fact that MySQL can run commands as the root user, we're going to classify as a threat. And we'll get to that a little bit later. So that was a lot of talking. This stuff is a little bit easier once you do it. We are going through a ton of information in a very short time. So I'm going to go through a very, very simple and not technically correct diagram. So if you want to talk about more detail type stuff, that's a conversation that we could have later. So let's build a product. And we're going to call it the Robo Kitty. So let's think, I am thinking of starting the hottest startup of 2020. My cats annoy me a lot at work. I want to build a toy that's going to entertain them as I am cranking out code. So I went ahead, I threw together a little prototype. It's a little Raspberry Pi Zero. I want to have a little web UI that I can control it from remote locations, and I'm going to run it in AWS. But right now, all I have is this questionable prototype. So the next thing I'm going to do is I'm going to start writing diagrams of what I want to build. One of the most powerful parts of threat modeling is you can do this before you write code. And that's where you're going to honestly see the most benefit. You can threat model something that already exists, but I would argue that it is significantly better to catch threats before you write the code versus going through and having to write a patch or a bug fix a couple months after you've introduced the vulnerability. So, as with most startup projects, we're going to start with a bar napkin diagram, right? And this is bare bones and a terrible diagram, right? It's pretty rough, it's hard to read, and it doesn't give us much information. If you're on a security team and you ask for a diagram from a team, it's sad, but you will run into these types of diagrams. So what you can do for your security team is not do this and go a couple steps forward. But we can see the general idea. We have a user that's going to talk to a web UI, a website. That's going to talk to our API, then the database, and then our Robo Kitty device, and ultimately the cat. So the first thing we're going to do is let's clean it up a little bit. So this is the same exact diagram, a little bit clearer. We've gone ahead and assumed that AWS is a trust boundary here. We know that these have different levels of permissions. versus like the web UI and the RoboKitty. We don't need RoboKitty spinning up S3 buckets, things like that. So this is helpful. This can help us start to identify different types of traffic, right? We know that we're going to have HTTP traffic going here. We know we're going to have to think about permissions going to the database and going back and forth to the RoboKitty. We start to think about user workflows and things like that. But we can go a couple steps forward and we can simultaneously remove some detail and add some detail. So here is what I'm going to stick with, right? For this example, we're going to keep things pretty simple. All right, we added a whole lot of different lines, but as I'm sure most of you have seen, much more complex data flow diagrams in your environments. But this will help us get the core concepts down. So we removed the web UI piece and combined that into just a user. Because in terms of this environment, we don't really control what that browser does. So all we really need to think about is the fact that we have an external entity that I'm calling a user, and it's interacting with our API. We know that users can proxy their web traffic. They can modify web requests. They can fiddle with the inputs, right? So we can't necessarily trust that data just because it came from our web UI. Further changes, we introduced another trust boundary here and another one here around our database cluster. If you've worked with AWS, that's great. If you haven't, that's okay too. Right now, we're using a service called Lambda that's going to let us run code without running servers. And once again, terribly simple diagram. We're just calling this API. This is going to be several different handlers running several different Lambda functions. But for the purpose of this example, we'll just go with API. So this API has vastly different permissions than anything running in this database cluster, right? So those are going to have completely different permissions, thus the trust boundaries between them. We've also created this trusted zone here for the RoboKitty device. And because we said earlier, it's a Raspberry Pi Zero, so a really tiny Linux computer, we have a separate user for our application running in there. So we're not running it as root. The reason why we put this trust boundary in here before is the application shouldn't be able to modify anything outside of this principle, this trusted principle here. So it's not going to be able to run things as root, etc., etc. And you can see we have data flows going here, here, and then to each of our functions within the RoboKitty device. So we have a good idea of what's going on. The most important thing about diagramming and when you're answering that what could go, or excuse me, when answering that what are we building question, you need to be able to explain your entire environment only referring to this diagram. A good way to tell if your diagram needs more detail is as you're explaining this diagram to someone who's never seen your environment before. If you have to refer to something that's not on that diagram, then you need to add more detail to that diagram. So, and obviously with bigger environments, that can be a problem, but that can be solved by having, sub-diagrams. So let's say RoboKitty was a huge infrastructure piece. We could have this just being a square and then linking out to another diagram, for example, if we needed to. So we have a serviceable diagram, right? Pretty good for a first crack. This is our first time threat modeling, and the device isn't even built yet. So let's go on and ask the next question. What could go wrong? Now, this is something that, once again, people often think is a very technical question, but you don't need a security experience to do this. The common misconception when people hear the word threat is that security people need to be involved. The best people to threat model an application are the people who built it. A security team, they might be very experienced in finding vulnerabilities and things like that, but they aren't experienced with how your specific application is architected. So how do we go about doing this, right? How do we get to the point where your project manager can help you threat model? How do we make sure that, non-technical people can have a seat at that conversation? So let's go through some tactics ranging in amounts of structure, going from unstructured and slightly chaotic to pretty structured and tame. Afterwards, we will revisit our Robo Kitty design. So the first one is pretty simple. It's a conversation. It's you and your team sitting around the diagram and just saying, okay, well, what could go wrong? There's not really a ton of structure. It's more of just a conversation. It's saying there's a lot of, well, what if this happened? What if, somebody starts modifying requests from the web browser? Can our API handle that? What if someone spoofs our API? What happens then? It's great to get the conversation going. And depending on the group of people, how technically inclined they are, how familiar with the environment they are, you can have varying results. And also, if you're trying to do a threat model with 30 people in the room, brainstorming can be very chaotic with multiple people trying to talk over each other. It's hard to track conversations, things like that. So it's not recommended as the only tactic for beginners. So adding a little bit of structure, a little bit more fun, is something called movie plotting. And the crazier, the better. This is where you start to have fun with your teams. And it sounds ridiculous. Stick with me. Solutions to outrageous threats can fix real world problems. So when you're movie plotting, you really need to step out of your work hat, right? You want to start thinking about solutions that are never going to happen. But what if, right? So what if, a meteor comes in and wipes out the US East 1 region in AWS? How do we ensure that people can still entertain their cats during the impending apocalypse, right? It's ridiculous. We're never going to have to worry about US East 1 going down because of a meteor. We have to worry about it going down for other reasons, right? But as we look into saying, okay, that's ridiculous, but let's fix the problem anyway. Looking into disaster recovery strategies is always a good thing. And being able to, survive a meteor taking out US East 1 is also going to help protect you from other sorts of things, right? It's going to help you, if that specific endpoint is getting hit with a DOS attack, you can fail over. If Amazon, someone at that data center trips over a plug, you can handle that. So what else? What if we talk about, non-technical things? Because not every threat model is about a piece of software. So what if a spy from an evil agency has crawled through the vents in our office and steals every laptop he could find? Right? Once again, ridiculous. But we go through, hypothetically, how can we solve this problem? And we start talking about better physical security measures. We talk about laptop drive encryption and requiring MFA to access critical systems. So starting with a ridiculous problem, we get serious results. Once again, not super structured. You're not going to get as many great results, but it's great to get the problem started and you get to have fun while you do it. Next thing we're going to talk about is evil user stories. And these are great because if your team is currently using user stories, you can use those as a starting point, right? So ask yourself, as you're going through this user story, what if the user made the worst decision possible at every step along the way? So it's a lot like QA testing, right? As you go through the flow of an average user, think about what if they had malicious intent? What if this user was hell-bent on breaking your application? Then what? And the last fun one is games, right? There are a couple games you can play. There's Elevation of Privilege, which was open sourced by Microsoft, which is a card game that you can play with your teams. If you Google Adam Shostak, he helped build it while he was working at Microsoft. It's on Amazon. It's great. And we'll talk about the specific framework that game uses later. And you can also do team happy hours, right? So this doesn't have to be a big, scary process for your teams. This can be, every Friday afternoon back when the pandemic isn't going on, or, over Zoom. You can sit down, look at your data flow diagram, and just have a happy hour while you look for threats. But for what we're going to use for the rest of our example, we're going to use something called the STRIDE framework. There are a ton of other frameworks, a ton of other mnemonics. I found this one to be the easiest jumping off point for teams with threat modeling, especially when they've never done it before. So the STRIDE framework was created by Microsoft for their security team, specifically for looking at threats. And like I said, it's a great way to start the conversation. And remember that it's really easy when you're starting threat modeling with Stride. It's just a mnemonic. It's not a strict rule. We don't want to force things into specific categories. We don't care about categories. We care about threats. So what is Stride? Stride, like I said, it's just a mnemonic. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. A lot of these are self-explanatory. Some of these are a little tough. So spoofing. Can something pretend to be something it's not? So can someone spoof my website? Let's say I'm trying to go to Google and someone has spoofed Google somehow, hypothetically. That is what spoofing is. Tampering. Can we modify data that we shouldn't be able to? Let's say we have a process that relies on a config file. Can a malicious user edit that config file to change how our application runs? The third one, the toughest one to explain and wrap your brain around, but we'll give it a shot. It's a repudiation. Can we prove a user did something? Or can a user make it seem like someone else did it? This generally revolves around logs. So if we have somebody that's hammering our database, do we have logs showing who it was? And can we attribute attacks to specific people? Once again, depending on your environment, that varies a lot. So repudiation is a bit nebulous, but whenever I think repudiation, I generally think, logs. Then information disclosure. Can someone sniff our traffic and read plain text communications? The difference between using HTTP and HTTPS in a coffee shop. It's not much of a problem anymore with banks, but if you go over your bank on HTTP and somebody is sniffing that traffic, that's not great. That's an information disclosure threat. Denial of service. Can we make it impossible for a service to be used? Self-explanatory. And then elevation of privilege. Can we execute an action that requires a higher permission than we currently have? So going back to our example, can the process running the RoboKitty execute root commands? I hope not. If it is, that is a threat. So we went through a lot there. Regardless of how you find threats, you must track them. That is the most important part. Without tracking threats, you're bound to repeat conversations and you're going to waste everyone's time, and nobody's going to want a threat model if they're constantly repeating their same ideas. It doesn't have to be crazy. As long as you can look back at all previous threats in an easy way, you're golden. And specifically because, it doesn't have to be crazy, we're going to use a really simple example that someone can use to get started in a very low-tech way. It's generally helpful to make slight modifications to your diagram to help with this. So with our example, we went ahead and we added a tag for each element so that we can easily refer to them. Depending on your environment and how crazy your diagram is, this may or may not be useful. You may have a ton of different tags. You might have to figure out something that works best for your team. So that might be specific tags in your environment, so on and so forth. And it may be easier to specifically tag the data flows between diagrams, depending on what types of threats that you're looking for. So once again, threat modeling, it's not a specific list of tasks, right? It is a way of thinking. So the most important thing is to do what works for your team. So let's go ahead and record some threats here. And we'll go back and forth to this diagram as we go along. So this is how I'm tracking threats for my, little startup of one employee. I have a tab for element 1, a tab for element 2, so we can see what relationship we're talking about. I have a category for Stride, categories, excuse me. So we can go through each one of those threats, or we can mark it as other, because if we find a threat that we don't think matches into Stride, that's okay. We just write it down. The important thing is that we know it's a threat. Then we have a short description. So between element 1 and 2, how do our clients verify they're talking to the correct API, right? So between here and here, how does the user know that they're talking to our API? How do we know that someone isn't spoofing our API? So this comes into play whenever they are authenticating to our website. We want to ensure that they're sending user credentials to the right place. We don't want an evil clone, on their local network just grabbing those sessions. So a way we can look at that is implementing SSL or things like that. And we go through, a couple different ones for tampering, repudiation, information disclosure, things like that. So for tampering, can someone modify the data in the database that will alter application behavior? Are we logging on that database? How can we prove someone is accessing privileged information? Can we sniff traffic? Can we constantly spam this laser stop function on the device? Does the device know that it's the API that's sending it data? Or can I specifically target someone's device and constantly spam that laser stop command, essentially rendering their device useless, because as soon as it starts up, it receives the stop command and it's dead. Or elevation of privilege. Can the user update a domain to be spoofed to deliver a malicious payload that can break out of the app's user space? Notice we have two tags here. We have spoofing and elevation of privilege. Just because it doesn't fit into one box doesn't mean you should force it into a box. Once again, we don't care about categories, we care about threats, right? So what I do whenever I'm looking at these things, because those can be kind of hard to just kind of grab out of the air if you're not familiar with them, I tend to look at where trust boundaries intersect with data flows and ask myself with stride, what could go wrong here? What could go wrong with spoofing here? What could go wrong with tampering data, with repudiation, with denial of service, things like that? And I generally go from intersection to intersection to intersection. And that gives you a great starting point of where to direct your focus. And generally, as you're with your team and as you're asking these questions, when you find one, you'll ask, well, what if this happens with a slight variation? And it starts the conversation in a bit more of a directed way. Okay, so we're going to move on a little bit. And now we ask, so we have this list of threats. Great. And, it might not be a lot. We just got started, but that's okay because we found some threats that we didn't know about before. This step varies a ton between organizations. So we're going to talk about it at a high level, and I'm not going to get into any specific products, workflows, things like that. The most important thing is to make this process fit your workflow. Threat modeling isn't supposed to be this huge disruptive thing to your software development lifecycle. You're supposed to tailor it to work with your current workflow. All right, because no good change is going to come from completely disrupting a workflow for this crazy new thing that no one even knows if it's going to be useful yet. So being able to work this into your existing sprints, maybe you have an hour every other week for diagramming new features, and then you have an hour at the end of every week for looking at threats there. Work it into your process. But when we're talking about specifically what are we going to do about it, threats are glorified bugs, right? You throw the big, bad, scary security word on there, and things seem a lot more intense. But threats are bugs, To fix them, you're either going to have to change how you write the code, remove a feature if it cannot be fixed, etc., etc. The same workflow you guys are using right now to fix bugs in your environment is the same workflow you could be using to be addressing threats, right? So ideally, as you identify threats in your environment, you're going to track them as if it was a bug, of course, with the correct prioritization. If you identify a threat that is super critical, you're going to want to push that to the top of your backlog or do it like a hotfix or something like that. But aside from that, you can assign them proper prioritization as long as during your backlog burn down, you're getting to these threats as well as your application bugs. It's critical that that happens. If you are just creating a bug ticket for threats, but they keep getting pushed to the bottom of the pile so you can fix application bugs, you're not fixing the problem, right? And the nice thing is, this can be done with whatever you're currently using for bug tracking and integrated into your current sprint. It doesn't matter if it's Jira, GitHub issues, Trello, sticky notes, or Slack messages to yourself. Whatever you're currently doing, you can track threats that way. The way you track them doesn't matter. What matters is that you are addressing these threats. So in my simple example, I updated my threat tracking spreadsheet. I went ahead and I added some fancy conditional formatting for the progress. And then I'm just linking off to my Jira project or my Trello board, whatever it may be. So as we're going through, we're doing our weekly threat modeling, we're identifying threats. We're not going to let that just sit there in Confluence or whatever it is and collect dust until the next time we want to talk about security. We are going through at the end of that meeting and creating a bug ticket for that to be addressed or for that to be looked into for each item. And it looks like a lot. For some of these, it might be as simple as looking at the bug ticket, taking a look at your environment and saying, hey, this isn't possible, or this is already mitigated because of X, Y, and Z, close. That's great, because the next time someone comes in and looks at this table, they can say, oh, I wonder how this is handled. Go check out the ticket or the wiki page, wherever you are writing out these threats, and they can see exactly how it's mitigated. This is fantastic when you start talking about compliance and working with your security team. Okay, and then this is also going to help you when you encounter similar threats in the future. You're going to have a living document. Whenever you see a similar type of spoofing threat, you can look back and see how it was mitigated in the past or how they looked at that problem. And over time, you'll start to build up this knowledge base of not only how these threats work, but how they work in your environment. So some natural questions. How do I fix a threat that we haven't written yet, right? This is all in my head. I haven't written any code. The answer is testing, right? It's super similar to QA. You write either unit tests, integration tests, whatever you're doing in your environment. But what you want to do is, let's say we have this spoofing threat that could be possible. We want to test if it's possible with a test, unit test or an integration test. We want to try to emulate a spoofing threat and see how your application reacts. And, with varying levels of success, depending on your application, your environment, you can have it either pass that test, fail that test, etc. Obviously, it's a lot easier said than done. It could require a lot of work in your environment. It could not. It could just be something that gets brought up during your design conversations if you don't have a robust testing environment. So ideally, unit tests. What is serviceable is bringing it up during architectural diagrams. Whenever you are talking about how you're going to build this, as long as you are aware of these threats and have ways to mitigate them. Maybe when you do write the code, you have proper validation, sanitization, etc. And by catching these threats before you write the code, you're preventing tech debt before it goes into your pipeline. And by doing that, you're saving countless of developer hours down the road. You identify this threat before you write the code. You're not having to go 3 months later, reverse engineer how the hell you wrote that one function and then fix the bug and then work through getting all those pushes up to date with your integration tests, etc. It just never exists in the first place. And thirdly, you're building a more secure product the first time, and it saves a lot of hassle for both you and your security team down the road. Like I said, this can be difficult depending on the systems. So like most teams, right, we already have stuff running in production. What if I find them in an existing system? Well, clearly, like we said earlier, you're going to use your team's bug tracking system. You're going to properly prioritize that threat as a bug, right? So if it's critical, hotfix. If it needs to get done now, great. Otherwise, properly track how critical those bugs are, those threats are, and work them into your weekly sprints, your bug burn downs, however your team does it, as long as you are addressing threats and you're cognizant of how they are working in your environment. And two, consult with your security team, right? Just because your security team isn't driving this effort doesn't mean they can't help. I, for one, would be thrilled if a development team came to me and said, hey, we've been working on this threat model. We found a couple things, but we're not sure how to fix it. That is rather unheard of, and you will be a favorite team. And afterwards, if you can, write tests to test for those situations in the future. If you can, you had to spend a little bit of time fixing this bug now, but if you can prevent that same type of issue in the future, you're going to save a lot of time later on. And getting close to wrapping up here, did we do a good job? This is a tough question. This depends heavily on your team and your culture, things like that. Consider it like a sprint retrospective. Are our diagrams complete? Well, can we explain the entirety of our project without referring to something outside the diagram? If not, you probably need to add a little bit more detail. How many threats did we find? If you only have 20 threats or 20 elements and found 7 threats, you're probably missing quite a bit. You're generally going to have more threats than you do elements, but it depends on your environment. Are we properly tracking and addressing threats? Are a certain percentage of those threats being triaged during your bug backlog, burn down, whatever you call it for your team? It's good to track, it could be on your threat tracking board to track, week over week, how many of those threats are being handled versus, how many application bugs that maybe aren't as critical. So maintaining that balance is going to be important. So what do I get out of this? Complete and accurate diagrams of your projects. Not only is this fantastic for security and compliance, but if you're onboarding a new engineer, now you have a set of diagrams that can be a one-stop shop for getting the general idea of application flow for your environment. You'll get a better understanding of your application and system. You will know exactly what talks to what and how it talks to it. No more, you have to talk to Dave for the database piece. You have to talk to Jerry for X, Y, and Z, so on. And you're going to understand your threat landscape. So as you're building this application in the future, you have a good idea of what threats you're going up against. You can't fix or you can't stop something from happening if you don't know what can go wrong in the first place. Thirdly, you're going to be constantly fixing security issues during your regular sprints. That's going to reduce the number of times that security hits the oh crap button. We have a critical vulnerability because it never got written in the first place, ideally. And by including your security team early and often, they'll be more equipped to help you whenever the time comes. And last of all, because this is a way of thinking, this is a way of operating your teams, you can tailor this to fit your process. There are no hard and fast rules on how you have to threat model. The important thing is you're asking yourself these questions and you're following up on the results. So you want to learn more, feel free to reach out to me. I'm always in the Code and Supply Slack, always happy to answer questions. And Adam Shostak formerly worked at Microsoft. He has some great resources. He has the book that lives on my desk, Threat Modeling, Designing for Security. And he also developed that card game, right? Elevation of Privilege. He has his website there, threatmodelingbook.com, for some great resources. And that is all I have. Thank you for your time. I know it's hard to squeeze an hour out of a busy schedule, and I appreciate it. Colin, you are on mute.
Let's do some Q&A. Anybody have any questions to ask? We are going to keep the stream on for now, and keep that in mind when you're asking. So if you have something you want to ask, and I can read it off and pitch it conversationally, or Jake can read it, or you can unmute and ask away. Anybody? I'm giving some moments for people to type if they're going to type. I know whenever I've been participating in a lot of online conferences over the last several months, and I know that there's times that I have to craft the perfect question, and that sometimes takes probably a good like 4 or 5 minutes just to like type the thing, and by the time I finally hit enter, like the moment is gone. We've already moved on to some other topic. Maybe while we're waiting for another question to come in, I'll remind some folks about the things that Code and Supply is pushing these days. The big one, of course, is our store at codeandsupply.co/store. We've got some really cool stuff. I really wish that I had my mug up here. It got dirty today, and I've been using it a lot because it's a really cool mug. It's right there on the top of the screen. I've seen a couple people on social media posting pictures of it. It's really cool. Our job board, codeandsupply.co/jobs. I think there's like 8 jobs on there right now. Various software engineering positions. There's an IT position, and I think there's even a design position on it. And then lastly, of course, membership. We'd love to see some more members help us carry through the storm of the pandemic.
All right, I see one question in the chat from John. So, can you carry over flaws from the previous threat models that might happen in a new app? If so, how is this done? Okay, so yes, and it depends, right? It depends on going from app to app, what similarities there are. You want your threat model to be pretty specific to your environment. That's not to say that the same threats can't happen. This is where you get into something that's a little bit more involved for threat modeling called a threat table. That is when you start to encounter these very common threats within your environment, you start to build up a bit of a database of common threats. So the next time, like you said, you're developing a new app, as you're looking through your threat model, you have your diagram built out, you can take a look at your threat table to look at all of the previous threats that have popped up in the past and see if any of them apply there. And that is a great way to start speeding up those sessions, those threat modeling sessions. And then how do you enable developers to be interested in security? So the nice thing about security is you don't need to be a security engineer to do it, right? And the big reason why I pitch threat modeling to development teams is there's no better team to do it, right? So me as a security engineer, I can get called into a team and say, hey, we want to do a threat model. But I'm gonna end up asking all of the questions that I've talked through today. I'm gonna say, okay, well, what are you building, and do you have up-to-date diagrams? You knowing your application, what do you think is going to go wrong? Because I don't know the ins and out of that application. So you as a developer, if you're interested in security, start threat modeling, right? Even if it's not something your entire team is doing, let's say you have a few spare cycles, you can start doing it on your own, and then show this to your Scrum Master, right? Show this to your project manager, and hopefully they'll see the value in it, right? It's often hard to pitch the idea of doing more work for something that doesn't necessarily generate a product. I've never heard of a threat table. Does Adam talk about it in this book? He talks about it a little bit in this book, and it's just something that kind of floats around. There's, like I said, there's many, many, many structures to doing threat modeling. Threat tables is just one of them. You can also get into attack libraries and things like that. Things like the MITRE attack framework can be used to give non-technical folks a bit of an idea on what is possible, right? Okay. How do you prevent malicious modules being used by developers? So that is a bit of an AppSec thing. It's not quite threat modeling, but there are products like Sneak and dependency scanning tools. I think GitHub acquired one, Dependabot, a while ago, that will go through like your NPM modules and things like that. To look for, vulnerabilities within those. But that's generally something you want to have tied into your CI/CD pipelines. All right, anyone else?
Cool. Maybe take one more Q to be matched with an A. That was a failed attempt at a slightly funny joke.
I
I can host these things, but I'm not a very good stand-up comedian. All right. Seeing none, I think we're gonna call it a night. Once again, let's all thank with some semblance of loudness or silence. If you want to unmute and clap for our presenter, feel free to do that approximately now. Thank you very much, Jake, for sharing a excellent talk with us. We're very happy to host you.
Yep. Thanks for having me.
Thank you.
Thank you.
And for those of you on the stream, thank you much for joining us. And we hope that you will catch us sometime in the future. I think our next talk is scheduled for September 30th, I think. Yeah, I think September 30th. So give it a shot. Check it out. Bye. And we're out.
Awesome. Yeah.